Hello everybody, welcome back to another edition of the Modicon M221. I'm your host, Leandro Mada, and in this video what we're going to see is the configuration that we have for the input on the PID assistant. So let's go to the presentation. So I have already explained that inside the M221, inside the software, we have a PID assistant that allowed us to configure the PID. Now that we have already seen the modes that we have, the different modes that we have on the PID, it's time to check what's going on with the inputs. So in this diagram over here, okay, when we open the assistant, okay, we have for the inputs, okay, we have 4 different fields that we can configure. We have measure, conversion, filter, and alarms. As you can see over here in the image, each of these components, once it's enabled, okay, you should be able to see different diagrams on the configuration of the device. So if we open a new project, Basic, just to show you what it meant, because by default the measure is going to be in our PID, because we need a variable, the measure variable from the process to control. So that would be in there, but we also have like additional features in order to scale the signal, like a conversion, and then we have the possibility to filter the signal, okay, and also we have the possibility to configure the alarms in case the limits of the converted signal goes outside those ranges. So if we go here, this is just a empty application, okay, just to show you what we got. So we go to PID, configuration, let's just to use PID. This is what we got for the input, just the measure. And if we click the measure or we go over input, it just go to the variable. And here we just need to complete. As soon as we add some of these additional configuration that we have for the input, it will add the diagram or the icon on the complete solution for the PID assistant. Okay, as you can see here, like a linearization. We also have the filter, and it adds this icon. And if we go over here and add the alarms, it will add like an indication. So the alarms will be influenced after the filter signal, not the measure after this. Okay, just to have an idea. Okay, so if we just close this part, okay, here is like an example of the variables that you need to use. We need to use %MW variables over here in all of them, except on the outputs of the alarms, because it will use a %M, or if I'm not wrong, you can use an output of the controller. So if we continue with this part, okay, we should be able to see more information. But basically, the measure is going to be the process variable, okay, the PV, that we are reading from the signal, from the process. And as I say over here, it could be %NW, or it could be linked to the analog input. If it's linked to the analog input, okay, then you should make the check on the conversion, because let me just open the basic again. I shouldn't have closed it. Just wait for it to open. Okay, open the other side. It's loading. Drag over here. So if you are using directly the analog input that you have on the controller, Okay, let's say that you are reading temperature, and then you just need to select one of these temperature that you have. You need to check which is the characteristics of the sensor that you're reading. Okay, but as soon as, for example, you use thermocouple, you have this minimum and max value. Okay, so you will need to convert that on the other side to go to 0 to 100 or 10,000, whatever you want, just to make it easy. But for example, you can use the analog input as a voltage or current, and if you use in that way, probably what you can do is to let's say voltage here, you can escalate it or leave it as it, okay, and then use the conversion just to specify, for example, if this value 0 is going to be I don't know 20, and this value is going to be 200. Okay, just to have an idea how you can make the escalation over here. Okay, so once you have the variable indicated over here, we just need to go, if you want, you convert the conversion, and in the conversion you have the minimum value and max value, and this can go from minus this value to this one, so you have the complete scale in order to make the conversion. Then after you have the signal already converted to the scale that you want, what you can do is to activate the filter. So you will make the filter on this base, and then just multiply by the number that you have on this percentage NW value that you have. Now let's talk about the alarms. So I'm going to put myself right here. So all these three options, 1, 2, and 3, are optional. It's not mandatory to use it, but if you use it, it's important to know what is all of them. So here, the alarms, okay? Once we activate alarms using this icon, okay, we must complete the low value and the high value and associate each of these values with the percentage M variable. So you can see over here. So if the alarm is activated depending on the value, PV system will give us a notification. Okay, doesn't say too much, but basically once the variable that you have defined in there converted, okay, for example, I have this value and I have this value converted to a signal like this, and if this signal is higher to the minimum and max level that I have defined, it will trigger an alarm. Basically, it's that. So in case you don't want to use this one, you can make your own, or this one, okay, you can make your own conversion without using the PID. It's one way to do it, and I will do it in that way, because if you use the conversion, okay, the conversion will also be taking place for the set point that you want. And in case you want to make, for example, to know the error that we have for the desired output, okay, that's going to be the set point, SP, and this one is going to be the process value. If you want to take a look at the error that you have for the PID just to know more, okay, what you can do is the following. You can assign the analog input that we have on the system, which is the percentage IW, to a percentage MW. Okay, so once you have this percentage MW, what you can do is to create some kind of conversion linearization using the raw values for the min and max, just to define 2 points, and another 2 points from the X and Y axis, in case you want to make the conversion, in order to make that linearization and then use the result over here. There's going to be this value, okay, percentage NW 10 in my case, just to have an idea how you can do it. In this way, you can calculate the error that you have just to validate the response. It's not mandatory to do it, but just an idea. So let's check the configuration that we have in our software. I made just a quick example, this one. So in my case, I can share that later. I had a possibility to simulate the input, okay? Let me just put myself over here. I had the possibility to simulate the input. As you can see, I'm using, let me just this. I'm gonna put myself over here. So as you can see here on the screen, I have a percentage IW 0.0. In this case, if I'm not wrong, is one of the analog inputs that I have already embedded over here. Yep. You can see the process value and it's the raw. So this one gives me a value from 0 to 1000, which is the voltage, to 0 to 10 volts. As in this case, I'm reading, I don't know, temperature. What I can do is to make a linearization. For example, the 0 volts is going to be minus 20 or 20 degrees, and the other one is going to be 200 degrees, whatever. So what I'm doing is to move the percentage I value, IW, the raw value, to a percentage NW, so I can work on this one. This variable over here, in my case, as I'm going to make a linearization, I'm going to convert it to a real variable. So this real variable is the one that I'm going to use on this function block that is scaling, and I believe already explained this scaling in a different video about the user-defined function blocks. And here you can see that I made the calculation from the offset and the slope for the equation, first grade equation, mathematical equation. So I'm using that one, and for this one I need 2 points on the rector of the line, and then what I need is the input, the variable that's going to be the process value. So I have this one moving to the scaling to the input, okay, and I have already defined pre-selected values for the minimum max. And over here, this one will give me the scaled output, okay, that's the one I can use on the PID. So if you check on the PID that I have over here, software's PID, this input percentage, I don't know if you can see it, but it says percentage NW 10.10, which is the one that matches over here, the one for the input of the PID, okay, the one I had configured. So in my case, I can simulate or not this behavior just to see what I'm doing. Okay. But as I don't have anything connected, no, I don't have anything connected on the analog input, I'm going to simulate the signal that I'm reading. So once you have that, okay, you just need to define the minimum and max values, okay, and in my case, I'm going to also to simulate the minimum and max values that I have and see the indications. So I have already specified also for the output, but the outputs will be taken in another video, okay. So I have the connection with the controller, and I have already created this PID over here. So in my case, I'm going to use PID, and I'm going to specify set point process value 300, conversion. Here I need to specify everything here. I haven't activated PID because it's over here. Okay, I haven't enabled it yet. That's why you see 0. I'm just going to put some values. I'm going to process value 0, KP 1. This one I just read out, doesn't matter right now. Okay, I just want to show you how it works. So alarm, this is the alarm that is going to be indicated, and if I'm not wrong, PID conversion min and max, max and output. Let's see if I already specify this or disable. In this case, I haven't configured the conversion, okay, which is fine. I just have the alarms, which is the percentage NW 10, 14, and 4 and 10, 15. So, which are these two values over here? So the minimum value is going to be, I don't know, 10, and the max value is going to be 400. Okay, so now I'm going to activate the PID just to see what do we have. PID. So as you can see, the output is doing something, but not pay attention to that one. Let's see what we got in terms of the alarms. As you can see here, the alarms, this one is activated. It doesn't activate this because the block is not working, okay? This part is not working over here, otherwise it would move the value and so on, so on. Okay, so we can continue now. Okay, so as you can see, the process value is 0 and it's below the minimum value that I have. So as soon as I increment this one, this value should be off. So if 5 is lower than 10, okay, okay, it's 10 is equal, so it's going to be 11, and it's working fine. Okay, so there is no issue. Now let's go to the other side, the upper side. So the max value is 400. So as soon as I reach, for example, 300, which is the value that I have for the set point, you can see that the PID state in this case reach the value, this value that indicates that the block, the PID block, reaches the set point. So now I'm going to increase this 350, and this one is going to be 390. Okay, and here I'm going to use 400. You can see it activates and activates. Okay, so this gives you an idea. Now if we go back to the previous part, that what I'm using this in this way is to calculate the error. As you can see here, this is not mandatory, but I'm using just to let you know how it works. So I'm going to calculate the error that I have between the set point and the value that is coming from the process. This error is not, this variable that I have indicated as error is not linked directly to the PID block. The PID block does this calculation. So here you can see that as soon as the error is close to the value, the incidence of the block and the output is going to be changed. We're going to see that later, but the changes are going to be more slow until it reaches, okay, and stay in there, the value. And as soon as I increase this, it was trying to reduce, just to giving the action to to the process, but we are going to cover this later. What I want you to know is that the different components that we have on the system, okay, and this is one way to do it. You can use the conversion and the filter. In my case, or most of the cases, I don't use it because probably I'm more confident doing it this way. I don't know why, but this is one way to do it, so I can check the error that you have. Okay, otherwise you will need to make another calculation in order to check what is the real error. So and this is it for the PID assistant related to the inputs, to the input that we have on the control. So thank you very much for watching this video, and I see you on the next one.